everyone! Today we're going to be learning about earthquakes. Our essential question for today is, why do earthquakes happen? And your objective is to be able to describe the anatomy of an earthquake. So here's a picture of what an earthquake would look under the surface of our lithosphere. Remember, the lithosphere consists of the crust and the upper mantle. So your epicenter is located here, and your surface waves that you experience when you see an earthquake will be at the top of your crust. Underneath, at the upper mantle, the focus of the earthquake will be located here at the center, directly below the epicenter, where body waves will radiate out from the focus. So let's ask ourselves, what is an earthquake? You guys have probably heard of earthquakes on the news. You probably associate them with places like California, where they are along fault lines. An earthquake is a sudden movement of the Earth's crust that is caused by the release of stress built up along fault boundaries. So there are different parts of an earthquake, which we just talked about in the diagram that I showed you about. The focus is the point inside the Earth, so at the upper mantle, where the earthquake starts. The epicenter is the location on the surface of the Earth directly above the focus, and the fault is the break in the crust where the earthquake occurs. So there's this thing called elastic rebound theory. So elastic rebound theory kind of describes the motion that the plate tectonics undergo when an earthquake occurs. So what you can see in this diagram on the left, you're looking at just a normal street. So at the beginning of an earthquake, rocks on each side of the fault are forced to move, but the rocks are locked together. So you see this would be your fault line, and these would be the rocks that are moving. So because rocks are locked together, they bend and they store energy like a coiled spring. So once the earthquake begins to occur, one side on the fault will move up, whereas the other side will move in the opposite direction. And then when these rocks are suddenly let go, they'll spring back. And this ultimately causes that earthquake. So this motion is the result of that. So let's recap really quickly on our diagram from before. We know there's the crust, the epicenter, we have our body waves, or also seismic waves, and we're talking about the lithosphere, but what is in the center? So if you got it correct, it is the focus. So we're going to move on to a second lesson just for time's sake. How is energy transferred during an earthquake? So we're going to be able to explain how the energy of earthquakes can be measured. So how do earthquakes cause damage? So what happens when an earthquake occurs is the energy flows out from the focus, from the center underneath the epicenter, in three ways. There are three types of waves, which we'll talk about, including the primary waves, or P waves, the secondary waves, or S waves, and surface waves. So what are P waves? P waves, remember, P stands for primary waves. So the initial jolt comes from the primary or P wave in an earthquake. It travels fast, and it alternately compresses and releases the rock like a slinky. So what are S waves? So the slower and stronger the primary wave, or the P wave, after that you'll experience the S waves, the second wave. So what happens is this causes the ground to shake in an upward and downward motion. And then surface waves. Surface waves travel horizontally across the Earth's surface. They are the slowest moving, but they are the most damaging because they are closest to our surface. So typically with earthquakes, the lower or the deeper the focus of the earthquake is into the upper mantle or below our crust, we won't typically feel those, but those that are earthquakes with a focus that is closer to the upper mantle or crust, you will experience those more because the ground will then roll in a sort of wave-like motion that causes us to feel it because we are closer to it. So why do scientists measure earthquakes? So scientists calculate the difference between the arrival of P waves and the arrival of S waves in order to determine the epicenter of the quake. So remember, the epicenter is the location that is directly above the focus. So how do we describe earthquakes? We describe them in two ways: intensity and magnitude. Intensity measures the amount of shaking at a location based on the damage, whereas magnitude measures the size of the waves and the amount of energy that is released in the earthquake. So although we describe earthquakes in two ways, the magnitude is more relevant to how earthquakes are described. So there are a few systems we use to measure earthquakes. The first being the Richter scale. So the Richter scale is based on the amplitude of the largest seismic wave recorded on a seismogram. A seismogram is a tool that we use to measure earthquakes. And then another system is the moment magnitude. This is based on the amount of displacement that occurs along a fault zone, and is a system that scientists use because it estimates the energy of the earthquake. So that really allows us to tell what the magnitude of the earthquake will end up being. So as I previously talked about, what types of earthquakes can cause the most damage. So earthquakes that have a high magnitude but are shallow, they are closest to the surface or closest to where we are located, those are the most damaging because we will feel the effect of those waves most immediately. Whereas those that have low magnitude and are close to the surface, those are the second most damaging. They are still damaging for the reason that is close to our surface. Whereas once you are in a deep earthquake with high magnitude, you don't really feel it as much, and with deep earthquake with low magnitude, that is usually where you really don't feel anything. So for your independent practice for today, you're going to work on learning how to read an S and P wave chart. So these are charts that kind of get spewed out with seismograms. You're going to need to use a lot of your prior knowledge from math to understand this graph. But we're going to walk through it really quickly. So you'll see that there is a vertical axis on this graph and a horizontal axis. The vertical axis represents time in minutes. So you see the travel time of the earthquake. So each of these segments is indicative of a minute. So if there are 60 seconds in 1 minute, each of these 3 segments that are located in this one segment is equal to 20 seconds. So you're just going to work through this independent practice to help you read seismographs. This PowerPoint is also located on Canvas, and you will be able to walk it through at your own pace. You'll get to read over the horizontal axis, see that it represents distance, not in feet, not in inches, but in kilometers. So make sure that you pay attention to those distinctions. All right, so that's it for today's lesson. Make sure you complete that independent practice, sign in for attendance, and check in during office hours if you have any questions. Have a nice day, everyone. Bye.